Acids and bases and how to spot them. So let's get right to it. Acids and bases. Let's see if we can name a few. Acids, stomach acid comes to mind. That's one that people often think of first. And then people often think of lemonade and orange juice. They think of citrus things. What's another acid? Oh, battery acid, sure. So, battery acid. And usually if you have people name some acids and bases, they come up with acids really easily, and then they can't name any bases because they can't remember their high school chemistry. But I'll tell you a couple bases. How about Tums? If you have too much stomach acid, then you take a Tums, and that neutralizes some of it. Tums is a base. Lye, drain cleaner. This stuff is very, very basic and very nasty. Another example of a base. How about ammonia? Ammonia is a base. Now there are certain things that you might remember that citrus things, especially if you talk about lemonade, that tastes sour. So acids tend to have a sour taste, whereas bases tend to taste bitter. If you have put your hand in ammonia before, you've noticed that it kind of feels slippery. Bases tend to have a slippery feel. And right after a chemistry book tells you that acids taste sour and bases taste bitter and feel slippery, the chemistry book will say, don't ever taste them. Basically, you're just supposed to kind of remember, oh yeah, okay, so something that tastes sour, chances are good that it's probably acidic. Okay, so how else can you identify an acid? Well, I did a quick Google search here and take a peek at what I got. Something is called litmus paper. It's this paper that has been made, it's been soaked in this vegetable dye. Different vegetables go into making it. And just cabbage juice will work to make this kind of stuff. And if you have pink litmus paper, if you dump it in, if you mix it with a base, it turns blue. And if you have blue litmus paper and you dump it in an acid, it turns red. And then there are all kinds of different shades of litmuses that you can get. I don't know if they're specifically called litmus then, but there are different tests. These are called indicators. Okay, so that's another way you can test them. Now, how do you spot an acid or base by its formula? I'm going to start with bases here because they're a little easier. Let me give you a base formula. This is a base, and this is a base, and this is a base, and you should be noticing a pattern. But then I throw in this, and you're like, oh crud, there goes my pattern. Well, the thing that you noticed was this, this, and this. And let's talk about where that comes from. So this OH thing, it has a name. It's actually called a hydroxide ion. And so whenever you have an oxygen and a hydrogen paired together in a formula like this, it's a hydroxide ion. Let me explain. What does this NaOH thing actually look like? Well, you've got an Na atom, and you've got an O atom, and you've got an H atom, sodium, oxygen, and hydrogen. And this stuff is called sodium hydroxide, by the way. And if you take this and you throw it in this glass of water here, you might have been wondering why I drew that, it splits into two pieces, not three. The Na splits off and it loses its electron, so it becomes a positive ion. And then the OH, they stay together, but they take that extra electron, so now they're a negative ion. So that is the giveaway right there. Anything that makes OH ions, or anything that makes hydroxides in water, is a base. And that's it. So that's how you spot a base. Now, all three of these, you got your sodium, calcium, and aluminum hydroxides here. But what about this one? This one doesn't have the OH. It kind of violates the rule. But when you take NH3 and throw it in the water, it actually interacts with the water particles themselves, and it still produces some of these OH negatives. So that's why ammonia is a base. All right. So that's how you can spot a base by its formula. Now let's talk about some acid formulas. Let's see, we got HF, we got HCl, we got HBr. How about this? H3PO4. What else? How about this? CH3COOH. So looking at these, you might start thinking of a rule that you could develop. You're like, oh, okay, they all start with H. Oh, rats. Then you wind up with this one. This one doesn't start with H. So that's a tool that you can use to look. If it starts with H, there's a chance that it's an acid, but it doesn't have to start with the H. Let's zero in on one of these. Let's zero in on this one. This one is stomach acid, HCl. The name of it, it's a hydrogen chloride. Let me clean this up over here. Okay, so we got hydrogen chloride. What does it look like? It's got a hydrogen atom and a chlorine atom. Guess what happens if they go into water? The H and the Cl split apart. The H loses its electron, the chlorine takes it, so now you've got these two ions. You've got this positive hydrogen ion and you got this negative chloride ion. So now, when it does this, we call it hydrochloric acid. All right, so here's the giveaway. Anything that makes these things in water is an acid. So what are these other ones called? This one's hydrofluoric acid, hydrobromic acid. This one's called phosphoric acid because it's got this phosphate group. We put that in soda. There's carbonic acid. There's tons of different acids. But look at this one, this last one here. This one is acetic acid, or this one is vinegar. It gets written funny. The reason why it gets written funny is because we could have written it like this. We could have written, what, C2H4O2. And I believe people used to write it like that. But then people couldn't notice as easily what was going on. What's going on with this is this group right here, this COOH group, that's called an organic acid group. And basically organic acids are things that are made, you know, naturally. And when you throw this into water, this H splits off as a positive ion, just like this one, and then this CH3COO thing is a big negative ion that's floating around. So while there are rules about how to spot acids, you know, they can start with H's, they don't have to start with H's. And then you could get picky and say there's other rules about acids and bases. For this class, just anything that makes an H plus is an acid, and anything in water that makes an OH negative in water is a base. That is plenty enough.